Number 1 says 2x plus 3y equals 5 and x equals 2y minus 1. So I've told you in the last statement there that x is the same thing as 2y minus 1. So if x is the same thing as 2y minus 1, I'm going to go into this other equation and change x into 2y minus 1. Makes sense. If x is 2y minus 1, make x say 2y minus 1. Well, as you can see now, the result there is a long equation, but it's an equation with only one variable now. It's just got y. So we're going to solve that equation for y. Now, we've been solving equations for a long time. So as far as solving that equation for y, use all those rules that you already know for solving an equation. Variables on the left, numbers on the right. A lot of simplification, but that's exactly what we're going to do here. So I'm going to go ahead and distribute this 2 through first because I'm taking 2 through to the 2y and 2 through to the 1 because it was 2 times whatever x is. Well, 2 through to the 2y is 4y's. 2 through to the 1 is 2. And all this stuff at the end is still there. Now, I'm going to put variables on the left and numbers on the right. So basically we're there. The only troublemaker here is this 2. He's a number. He should be over there on that right side. So we're going to send 2 to the other side. And of course, when I move something to the opposite side of the equal sign, I do the opposite. That's always how we solve an equation. Now over here on this left side, I've got 4y plus 3 more y's. That's going to give me 7y's, and it's going to equal 5 plus 2, which is 7. So if 7y is 7, that means y has to equal 1, because 7 times 1 is 7. And now you solved half of the system of equations. Now what you want to do is you want to go ahead and go back to your original 2 equations. Pick one. It doesn't matter. You're going to get the same answer, but you got to pick one. I'm going to pick this bottom one. Now that we know that y is 1, I'm going to change y into 1 and solve it. So if I pick x equals 2y minus 1, I'm going to change y into 1. So it's going to say 2 times 1 minus 1. 2 times 1 is 2, and 2 minus 1 is 1. So x has to equal 1. Well, I found x, I found y. That's the solution to my system of equations, because remember when we did the graphing, it was the point x comma y at which they overlap. I have x, I have y. So my x comma y set here is 1 comma 1. The values that I plug in for x and y in both equations at the same time to make the left side and the right side equal out are x is 1 and y is 1. All right, let's try that again in number 2. 4x plus y is 3. And y is the same thing as x minus 2. So if I'm telling you that y is the same thing as x minus 2, I'm going to go up here and change y into x minus 2. So I do that, and I've got 4x plus x minus 2 is equal to 3. Solve the equation. Well, that's maybe even a little bit simpler than number 1. Variables on the left. Got that, that's good. Numbers on the right. I do have 3 over there, but I need to send 2 over there to match up. I'm going to move 2 over by doing the opposite, which is adding 2 to both sides. So I do that. I got 4x and x still hanging out there on the left side. That's going to give me 5x's. And I got 3 and 2 over here, which is going to go together to make 5. So I've got 5x equals 5. Well, if 5x equals 5, of course, that means that x equals 1. 5 times 1 is 5. So if I now know that x is 1, I'm going to go into one of my original 2 equations and change x into 1 and solve. So I'm going to go ahead and pick the bottom equation again. Notice I tend to pick the equation that looks shorter. Good technique. All right, so I've got y equals x minus 2, but I've just found out that x is 1. So change x into 1. So I've got y is the same thing as 1 minus 2, or y is the same thing as negative 1. So the solution to the system of equations is 1 comma negative 1.